Scientists' perspective of the solar system has changed dramatically since NASA's Juno probe arrived at Jupiter in July 2016. The $1 billion project captured incredible photographs of the gas giant, hundreds of millions of miles away from Earth. More crucially, the tennis court-sized spacecraft has used a suite of high-tech instruments to study some of the planet's deepest, darkest secrets. So what did the Juno spacecraft find on Jupiter? What other spacecraft sent us back unexpected findings from the gas giant? And why has the latest discovery left scientists completely baffled? Well, let's find out. Jupiter is sometimes referred to as the king of planets because of its size and prominence in our solar system. The reason for this is that it is the largest. The term kinghood has been used in several societies throughout history. It's brilliant and it shines out against the night sky. Amazing photographs from spacecraft show that the exploration of Jupiter has been going on for hundreds of years and is still going on today. Every 12 Earth years, Jupiter makes a complete circle around the Sun. Jupiter has a long year due to its distance from the Sun of 483 million miles, or 778.5 million kilometers. The longer it takes for a planet to complete one orbit, the further away it is. Long-term watchers will see that it passes in front of each constellation for around a year. Even though Jupiter has a very long year, it only has a few hours of daylight. One revolution around its axis occurs approximately every 9 hours and 55 minutes. Cloud belts and zones are formed as various sections of the atmosphere rotate at different rates, creating powerful winds that sculpt the clouds. Jupiter is the most massive planet in the solar system, with a mass 2.5 times greater than that of other planets. Because of its enormous mass, it has a gravitational force that is 2.4 times greater than that of Earth. Jupiter is also a kingly figure in terms of size. It has a diameter of 273,000 miles, or 439,264 kilometers, and a volume huge enough to hold the mass of 318 Earths. Jupiter's atmosphere, unlike Earth's, stretches to the core and touches all of the planet's continents and oceans. It is not, however, gas all the way down. Higher pressures and temperatures cause hydrogen to become a liquid at some point, and it turns into a metallic liquid as it gets closer to the core, encasing a little rocky inner. Jupiter has a swarm of moons. According to planetary scientists, there are more than 60 small bodies orbiting Jupiter, and there are most likely at least 70. Io, Europa, Ganymede, and Callisto, the planet's 4 largest moons that orbit close to it. The rest are smaller, and many of them could be asteroids that have been captured. When we first learn about the solar system as youngsters, we are taught that the planets all orbit the Sun in their separate orbits. If you were one of the many individuals who were astonished and even upset to find that Pluto isn't a planet, you might want to brace yourself for yet another surprising cosmic discovery. Jupiter does not actually revolve around the Sun, but it still does have an orbit. None of the planets revolve around the Sun in a perfectly round path. In actuality, the Sun and other planets orbit a common gravitational core. Because the Sun is so much larger than Earth, our center of gravity is near to the center of the Sun, giving the impression that we are traveling in a circle around it. This is also true of every other planet, with the exception of Jupiter, the gas giant. Now, if Jupiter isn't orbiting the Sun like the rest of the solar system's planets, what exactly is it doing? Jupiter's size causes the Sun's center of gravity to be pulled away from the Sun's center to around 30,000 miles above the surface. That means that the Sun and Jupiter are both orbiting the exact location in space. The barycenter is the technical term for that position. Unlike the other smaller planets, Jupiter does not orbit the Sun in addition to this combined center of gravity, since the point is dragged away from the Sun's center. Jupiter's gravitational pull causes the Sun to wobble slightly. All planetary bodies have a shaky relationship, but Jupiter is the only one large enough to make the effect obvious. Contrary to popular belief, Jupiter even has its own ring system. If you have everyone draw the planets, you'll probably end up with some big ones, some small ones, and just one with rings, which would be Saturn. But that is incorrect. Jupiter, Neptune, and Uranus all have rings, although they aren't as apparent as Saturn's. The discovery of a thin dust ring encircling Jupiter is one of the most significant achievements of the Jupiter exploration era. Voyager 1 captured a photo of it in 1979, but the Jupiter ring is not really a visible ring set. According to planetary experts, the majority of the system's dust comes from a few minor moons. Astronomers have been captivated by Jupiter for a long time. Galileo used his telescope to study the globe after he developed it. He was taken aback by what he saw. Around it he saw 4 small moons. Astronomers were able to see the cloud belts and zones as their telescopes improved. Spacecraft have sped by in the 20th and 21st centuries, taking ever better photographs and data. The Pioneer and Voyager spacecraft were the first to conduct up-close investigations, and the Galileo spacecraft completed the series by circling the planet and doing in-depth observations. Also, the Cassini probe to Saturn and the New Horizons spacecraft passed by and collected data. The extraordinary Juno mission, which has obtained exceptionally high-resolution photographs of the gorgeous clouds, was the most recent mission expressly aimed at studying the planet. Jupiter's poles have never been photographed from above or below before Juno arrived in July 2016. The probe sailed across Jupiter's poles and returned data that left scientists in awe for the first time. Although observatories such as NASA's Hubble Space Telescope had detected auroras at Jupiter's poles, no one had previously viewed the enigmatic regions in detail shown by Juno. We've never seen or imagined anything like that. There are a lot of storms up there, and the sky is bluer than anywhere else on Earth. Latitudinal bands, zones, and belts are nowhere to be found. In fact, it's hard to tell if this is even Jupiter in the shot. In addition, the planet's weather is significantly more complex than previously assumed. Juno's initial close approach allowed scientists to peel back Jupiter's atmospheric layers like an onion, revealing hundreds of kilometers of hydrogen, helium, and other chemicals. The zones and belts structure can still be found deep down. So, whatever is responsible for those colors and stripes is still alive and well deep within Jupiter. Many of the scientists were taken aback by this. According to further research, belts and bands may start more than 1,900 miles beneath the gaseous surface of the planet. In addition, NASA provided stunning photographs of symmetrical storm clusters. Multiple shots were taken in infrared light, a wavelength that is ordinarily invisible to us, were used to produce the images. The scientists then combined the images to make them 3D models, emphasizing brightness and temperature. Also, Jupiter's Great Red Spot indicates that the planet is water-rich. Many of Jupiter's moons have water and may even have large oceans that aliens may live in. However, Jupiter appears to be dry on the surface, and finding evidence of water molecules within the planet has been challenging. With its suite of sensitive instruments and ultra-close flybys, Juno is tackling this dilemma. Juno's data was coupled with data from the Great Red Spot acquired by telescopes, giving researchers a more detailed glimpse of Jupiter's atmosphere. They determined that the planets may have 2 to 9 times more oxygen than the Sun, and we all know how essential oxygen is for water. Furthermore, Jupiter may have a fuzzy core that is far larger than previously thought. In the depths of Jupiter, hydrogen resides in a semi-gaseous, semi-dissolved condition, hence the term fuzzy. In contrast, Earth has an outer liquid that moves around a solid core. Jupiter's magnetic fields and dynamo may be powered by its fuzzy core, similar to the metallic dynamo in the Earth's core. Previously, it was thought that Jupiter's magnetic fields were caused by hydrogen, which is usually a gas, but had been compressed into a liquid metal state. Even now, the experts are unsure. That's not the only thing about the planet that's puzzling. Jupiter's auroras are strangely being propelled by an enigmatic force. The magnetic field of a planet is the source of auroras. This field collects charged solar particles that are thrown into space and races them towards the planet's poles. When the particles collide with gas atoms in the atmosphere, they produce a spectacular light display. However, Juno scientists revealed that Jupiter's polar auroras had 10 to 30 times more energy than expected, and that this energy is primarily released in ultraviolet light, which is undetectable to humans. Furthermore, when the globe spins into darkness, the auroras dim. Jupiter's auroras are still a mystery to scientists, but they believe it has something to do with the planet's enigmatic plasma field. Moving further, Juno found evidence of a new volcano that may have formed on Jupiter's moon Io. Juno's infrared camera discovered what appears to be a previously unknown volcano on the moon. It is estimated that the world has 150 active volcanoes. Still, the amount of material erupting from the planet's surface and traveling into space suggests that there may be an additional 250 lurking in the shadows. It's a powerful reminder of how small we are and how much more there is to discover in the world. Thanks for watching another episode of Voyager. And while you're still here, make sure to click the video on your screen for more high-quality content. I'll see you there.